To start, the outer ear contains the pinna and the external auditory canal. The pinna is made up of elastic cartilage, and its function is to collect sound waves from the environment. Then, it transitions into the external auditory canal. The external auditory canal is where you can find modified apocrine sweat glands called ceruminous glands that produce cerumen. This wax traps foreign material and repels insects. As the collected sound waves travel this canal, it now funnels and amplifies the sound waves towards the start of the middle ear structure, the tympanic membrane.
The middle ear is home to the tympanic membrane, which is also known as the eardrum. The three auditory ossicles, which are known as the malleus, the incus, and the stapes, as well as the pharyngotympanic tube, which is also known as the eustachian tube. As sound travels through the external auditory canal and hits the tympanic membrane, it creates vibrations that directly transfer to the three tiniest bones in your body, which are the ossicles. The malleus, incus, and stapes then amplify the sound waves with vibrations while projecting it onto the oval window. Otosclerosis is a common cause of hearing loss due to the hardening of the ossicles, which inhibits the conduction of vibrations. The pharyngotympanic tube connects the middle ear and the pharynx. The pharyngotympanic tube is normally flattened and closed, but it opens momentarily while swallowing or yawning to equalize pressure in the middle ear cavity with external air pressure. This is crucial because the eardrum will only vibrate freely if the strain on both of its surfaces is equal. Otherwise, sounds would be distorted. The inner ear is composed of two sections, the bony labyrinth and the membranous labyrinth, which is contained within the bony labyrinth. The bony labyrinth consists of the cochlea, the vestibule, and the three semicircular canals. As the ossicles from the middle ear hit the oval window, this is where the fluid inside the cochlea is being stimulated. The fluid in the bony labyrinth is called perilymph, while the fluid in the membranous labyrinth is called endolymph. This is the stage where the mechanical energy is being converted to electrical energy. The cochlea houses the cochlear duct, which is shown in pink over here, and it contains the spiral organ, which is also known as the organ of Corti, and it's the receptor organ for hearing. Shown again over here, you can see that this is the cochlear duct in green. Within the cochlear duct, the hair cells rest on the basilar membrane, and the hairs project into the gelatinous tectorial membrane, which is shown in red over here. The cochlear duct is also called the scala media, and it contains endolymph. The vestibular duct and the tympanic duct are called the scala vestibuli and the scala tympani, and they both contain perilymph. Low frequency sounds disrupt the cochlea at the apex, while high frequency sounds disrupt the cochlea at the base. When vibrations cause the hair cells also called stereocilia, to bend towards the tallest hair. Depolarization occurs, sending glutamate via the cochlear nerve to the brain, which allows us to hear. However, if the hair cells turn towards the shortest hair, then hyperpolarization occurs and no impulses are sent to the brain, and we will not be able to hear.